Hello and welcome to the AI Research Roundup. I am Alex, your host. Today is May 9th, 2025. We are diving into a research paper from Hugging Face's trending list, published just 4 days ago, called ReplaceMe, Network Simplification via Layer Pruning and Linear Transformations. This paper introduces a method for depth pruning, that is, a way to make large AI models, like large language models or LLMs, simpler. It works by removing some of their core components, known as transformer blocks, and replacing them with a simpler mathematical step, a linear transformation, all without needing costly retraining. Alright, so this first figure really highlights the advantages of this training-free approach. It compares the proposed method labeled hours, which has two variations shown, hours LS using least squares and hours cosine using cosine distance, against another technique called UIDL. We see three key comparisons. First, the healing time, which is essentially the time needed to retrain or adjust the model after parts are removed, is dramatically lower for both hours variations. Second, these variations also show much lower environmental impact. And finally, for relative accuracy, hours cosine performs best. Building on those advantages, this next figure visually explains how the ReplaceMe method works. We see a series of transformer blocks, the fundamental processing units in these large models. Each block contains components like normalization, or norm, for data stability, multi-head attention, to weigh input parts, and a multi-layer perceptron, or MLP, a type of feed-forward neural network. The core idea, highlighted by the red line, is that some blocks are skipped. A linear transform takes the output from an earlier block's multi-layer perceptron and feeds it directly to a later block, pruning those in between. Okay, so to see how well this ReplaceMe method actually performs after such pruning, this table presents a detailed comparison. It shows the Llama 2.7b model, a specific large language model, after 25% of its depth has been pruned. The RS methods, which are training-free, are compared against several other techniques that do require retraining. This comparison is done across various tests of language understanding and reasoning, like MMLU and HelloSwag. The final column, relative performance, which is how close the pruned model's performance is to the original, shows R's cosine achieving 92.5%, demonstrating its effectiveness without costly retraining. Expanding on that strong performance, this next figure offers a broader comparison. It plots accuracy on the vertical axis against the number of pruned layers on the horizontal. This is for three different large language models, Llama 3.8b Instruct, Falcon 2.11b, and QN 2.57b Instruct. The solid lines, showing the ReplaceMe Atom variant of their method, consistently achieve higher accuracy than the dashed lines, which represent the UIDL method. So, as more layers are removed, ReplaceMe still performs better, highlighting its robustness across various models. Alright, so building on that robustness, this figure explores a key aspect of ReplaceMe's efficiency, the calibration data. This small dataset helps estimate the linear transformation, avoiding lengthy retraining. We see the Llama 3.8b model, with 25% of its layers pruned. On the left, average accuracy stays quite stable for both least squares and cosine methods, even with few calibration samples. On the right, perplexity, a measure of how well the model predicts upcoming text, lower being better, improves with more samples, especially for the cosine method, before stabilizing. This shows effective estimation with limited data. So we have seen how ReplaceMe works efficiently with limited data for large language models. This table now shows its versatility, extending to vision transformers, which are models for understanding images. It examines the CIP-L/14 model, a model connecting images and text, after 13% and 25% compression. Notably, with 13% compression, performance is nearly that of the original model. ReplaceMe, using the least squares method, is compared to UIDL on tasks like CIFAR 10 zero-shot image classification. Zero-shot means testing on tasks the model was not directly trained for. Across these visual tasks, ReplaceMe consistently outperforms UIDL, showing strong generalization. So, as we have seen across both large language models and vision transformers, This method offers a really clever approach to model simplification. The key idea is that you can significantly shrink these big models by removing entire layers, a process called depth pruning, and cleverly replacing their function with a straightforward mathematical adjustment, a linear transformation, all without needing to retrain the whole thing. This really helps make powerful AI models more accessible. Well, that is all for this AI Research Roundup. Thanks for tuning in.